Early ancestral bottleneck could have spelled the end of modern humans. The population crashed following climate change about 930,000 years ago, scientists concluded. Other experts are not convinced by the analysis. How a new method of inferring ancient population size revealed a severe bottleneck in the human population, which almost wiped out the chance of humanity as we know it today. An unexplained gap in the African-Eurasian fossil record may now be explained thanks to a team of researchers from China, Italy, and the United States, using a novel method called FIT-COAL, Fast Infinitesimal Time Coalescent Process. The researchers were able to accurately determine demographic inferences by using modern-day human genomic sequence from 3,154 individuals. These findings indicate that early human ancestors went through a prolonged severe bottleneck in which approximately only 1,280 breeding individuals were able to populate for about 111,000 years. And while this research was illuminated some aspects of early to middle Pleistocene ancestors, there are many more questions to be answered since uncovering this information. A large amount of genomic sequences were analyzed in the study, but the fact that FIT-COAL can detect the ancient severe bottleneck with even a few sequences represents a breakthrough, said senior author Yun-Xin Fu, theoretical population geneticist, University of Texas Health Science Center at Houston. Researchers will publish their findings online in August. Well, they did publish them in August. The results determined using FIT-COAL to calculate the likelihood of present-day genome sequences found that early human ancestors experienced extreme loss of life and therefore loss of genetic diversity. The gap in the African and Eurasian fossil record can be explained by this bottleneck in the early Stone Age, as chronologically it coincides with this proposed time period, a significant loss of fossil evidence, says senior author Giorgio Manzi, anthropologist at Spezia, University of Rome. Reasons suggested for this downturn in human ancestral population are mostly climactic, that is, the Ice Age glaciation events around this time led to changes in temperature, severe droughts, and loss of other species, potentially used as food sources for ancestral humans. An estimated 65.85% of current genetic diversity may have been lost due to this bottleneck in the early to middle Pleistocene era, and the prolonged period of human numbers of breeding individuals threatened humanity as we know it today. However, this bottleneck seems to have contributed to a speciation event where two ancestral chromosomes may have converged to form what is currently known as chromosome 2 in modern humans. With this information, the last common ancestor has potentially been uncovered for the Denisovans, Neanderthals, and modern humans, Homo sapiens. We all know that once a question is answered, more questions arise. The novel finding opens a new field in human evolution because it evokes many questions, such as the places where these individuals lived, how they overcame the catastrophic climate changes, and whether natural selection during the bottleneck has accelerated the evolution of human brains, says senior author Yi-Xuan Pan, an evolutionary functional genomics of East China Normal University, ECNU. And now that there is reason to believe an ancestral struggle occurred between 930,000 and 813,000 years ago, researchers can continue digging to find answers to these questions and reveal how such a small population persisted in assumably tricky and dangerous conditions, the control of life, as well as the climate shifting to be more hospitable for human life, could have contributed to a later rapid population increase around 813,000 years ago. These findings are just the start. Future goals with this knowledge aim to paint a more complete picture of human evolution during this early to middle Pleistocene transition period, which will in turn continue to unravel the mystery that is early human ancestry and evolution, says senior author Li Haipeng, theoretical population geneticist at Shanghai Institute of Nutrition and Health, Chinese Academy of Sciences. The research was jointly led by Li Haipeng at SINH and Yi Xuan Pan of ECNU. Their collaborators, Fabio De Vincenzo, University of Florence, Giorgio Manzi, Spezia, University of Rome, Juan Huiquin Fei, University of Texas, Houston, have made important contributions to the findings, and the research was first authored by Hu Wanji and Hao Ziquan, who used to be students at SINH. They are currently affiliated with Icahn School of Medicine at Mount Sinai and Shandong First Medical University, respectively. And this is on Collective Spark. Please leave your comments and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.